Most QA testers think security testing is someone else's job. It's not. And the most common security bugs are found exactly the way you'd find any other bug. You just need to know which inputs to try and which flows to test. Today, Claude tells you exactly that. Subscribe so you don't miss the rest of Module 3. And if you find a security issue this week, drop it in the comments. I'll help you write the report. Here's what we're covering. First, why security testing belongs in the QA process, not just with a separate security team. Then the OWASP Top 10, the industry standard list of the most critical web vulnerabilities, explained simply with test examples. We'll use Claude to generate targeted security test cases for a real feature. Then, I'll give you 15 manual security tests across 3 key areas that you can run today. And finally, how to write a security bug report that communicates the actual business risk, because a report without context doesn't get prioritized. Let's address the myth first. Most teams assume security testing is only for dedicated security engineers or penetration testers. The problem is that most companies don't have either, and even those that do only test before major releases. Meanwhile, months of new code gets shipped without any security checks at all. Here's the important thing. Most security bugs are not exotic or complex. A login that doesn't lock after failed attempts. A URL with an ID you can change to see someone else's data. An input field that executes a script. These look like functional bugs. You'd find them during normal exploratory testing if you knew what to look for. And the cost difference between finding them in QA versus after a breach is enormous. We're talking hours versus millions. Claude knows the OWASP Top 10 and applies it automatically. You just describe the feature. The OWASP Top 10 is published by the Open Web Application Security Project, a nonprofit that tracks the most common security risks across thousands of web applications worldwide. Let's go through the first 5. Number 1 is broken access control, found in 94% of all apps tested. It means a user can access data or actions they shouldn't be allowed to. The test is simple. Change a number in a URL and see if you get someone else's data. Number 2 is injection. SQL injection is the classic version. You put malicious code in an input field and it gets executed. Number 3 is broken authentication. Login flows that don't lock after failed attempts or sessions that don't expire. Number 4 is cross-site scripting, or XSS, scripts injected into pages that other users see. And number 5 is security misconfiguration, error messages that reveal too much about the system underneath. The second 5 are slightly less common but equally important. Number 6, vulnerable components. If the app is built on a library with a known security hole, it inherits that hole. Number 7 is authentication failures beyond just brute force. Weak password reset flows, no multi-factor authentication. Number 8 covers data integrity failures. The app trusts files or external data without verifying their contents. Number 9 is logging failures. If nobody is alerted when 50 failed logins happen in a minute, an attack can run for hours undetected. And number 10 is server-side request forgery. The app makes requests to URLs that users control, potentially exposing internal systems. As a manual QA tester, focus your energy on numbers 1 through 4. They cover 80% of what you'll actually find in a standard web app. Here's the prompt for the ShopMate login page. Role: QA tester with knowledge of web application security at OWASP Top 10. Context: we describe the login page. Email field, password field, forgot password link, login button, what happens on success and failure. Task: generate security test cases a manual tester can execute without special tools. Format: test ID, attack type, exact input to use, expected safe behavior, and risk level. Look at what comes back. SQL injection. Enter a specific string in the email field and see if the page behaves differently. Brute force. Attempt 10 failed logins and check if the account locks. XSS. Enter a script tag and check if it executes. Verbose error messages. Try 2 different wrong inputs and check if the error is the same for both, and password reset link expiry. All 5 are tests you can run right now with nothing but a browser. This slide is your security testing starter checklist. 3 areas, 15 tests, all executable manually with just a browser. Input fields: try SQL injection strings, script tags, extremely long inputs, negative numbers in price fields, and email addresses with script content to see if they get stored and displayed to other users. Authentication and sessions: test for account lockout. Check if the back button brings you back after logout. Copy a session cookie and try it in a new browser. Use a reset link twice and leave the session idle to see if it expires. And URL and access control: change ID numbers in URLs. Try accessing admin pages as a regular user. Remove the auth token from a request. Add role parameters to URLs and navigate directly to protected pages without logging in. These 15 tests alone would catch the majority of security bugs in a typical web app. The security bug report format is different from a regular bug report, and that difference matters. A developer who receives "login doesn't lock" after failed attempts will triage it as medium and schedule it from next month. Look at Claude's report. Same bug, but now it tells the developer exactly what an attacker can do. Run an automated script, try thousands of common passwords, compromise any account with a weak password, access all user data, orders, and payment methods. That context changes the priority entirely. The report also includes the OWASP reference number, so the developer can read the full technical detail if needed, and specific recommended fixes. Lock after 5 attempts, add exponential delay, implement CAPTCHA. P1, fix before next release. The difference between a security bug that gets ignored and one that gets fixed this sprint is the quality of the report. Let's wrap up. Security testing is no longer someone else's job. It's part of every tester's role. Today you learned the OWASP Top 10, all 10 vulnerabilities explained with real test examples. You used Claude to generate a full security test pack for a login page. You have 15 manual tests across the 3 most vulnerable areas of any web app. And you have a bug report template that makes sure security issues get the priority they deserve. In video 14, we move to a different challenge: understanding complex features. How to use Claude when you're given a spec you don't fully understand and need to build a testing strategy quickly. Subscribe so you don't miss it. And if you find a security vulnerability this week, comment below or email me. I'll help you write the report.